Hello everybody and welcome to this bonus lesson on short division. This is an introductory lesson for those people who are struggling with short division. We're going to start off very much with the basics, just run through the process, how to set out, how it should look, how it works. We're going to try a variety of questions, so you can also watch this video and just skip ahead to the questions where you'll get nice questions and answers where you can give them a go and see how you're getting on. Now this pairs quite nicely with a much harder challenge edition video, this version, which looks at some of the hardest divisions you could expect to see, which is more of the two-digit division end. So I'd certainly recommend starting with this one first, especially if you find division something you struggle with. Equally, if you're just here for more additional practice and you feel like you've got the basics, you know how division works, you may want to look at that harder division video and see if those challenging questions are more your speed. Right, we'll jump into it and see how we get on. So, quick overview of what we're going to look today. So we're going to understand the terminology around division, the dividend, divisor and quotient, how we place them in the bus stop. We're going to look at short division where all the digits are multiples of the divisor. That means there'll be no remainders left over. We're going to perform short digits where the divider does not go exactly. Those are kind of questions that are going to result in a remainder. We're going to perform some short division where the divider is larger than the first digit. We're going to talk about what happens in that case when you're trying to divide, for example, so you're dividing 8 into 203. That 8 won't go into that first 2, so we'll see what we do in that situation. And finally, we're going to just look at some short division involving decimals and see if that puts us off or if we can figure out how to go right. So, to start off with, here is a classic question. We have 528 divided by 3, and we have the correct answer, which is 176. So, I would like to just ask, have a go now please, have a go at putting the question part of this into a bus stop. Where do you think it goes? And have a go, if you wouldn't mind as well, try and have a guess or work out what the names of each part is. So what is the divisor, the dividend, and the quotient? And even if you're not sure, feel free to have a guess and we'll go through the answers. So pause the video now, and I'll go through the answers in just a moment. Okay, hopefully you've had a go at doing that. Well done. Let's look at the answers now then. So, this is how I would set the bus stop out, where we're dividing by 3. And so the number we are dividing by goes on the outside. Please note it's not because it's the smallest number, it's because that is the number that is after the divide sign, and so that's what we're dividing by. The answer to the question is the quotient. Bit of an old-fashioned word, it's a bit less out of favour now, but it's just nice to see just in case it ever comes up. The divisor, a bit like the divider, the number we're dividing by is on the outside, and the dividend is the answer, is the number that is being divided. So the dividend is what's being divided, the divider is what you're dividing by, and the quotient is the answer. Nice bit of revision, just in case these terms ever come up, you'll know what they mean. Interesting question here. Always, sometimes, or never? The smallest number always goes outside the bus stop. And this is my question. I may have given the game away slightly. Have a pause, have a think, let me know what you think, and we'll come back to it. Okay, well let's talk it through. And actually, the answer is sometimes, but certainly not always. So if I was to do, for example, 100 divided by 10, in this case, the 100 will go inside the shelter, and the 10 would go outside. That would be how we would start the question off. But if, for example, I was to swap those round, and I was to do maybe, for example, 10, or let's do it this way, let's do 5 divided by 10. In this case, the number I'm dividing by is the 10. So the 10 will actually go on the outside. And we can look at questions like this perhaps towards the end with our decimals, how we would approach them. But the answer is not always, and that's a very common misunderstanding that people always do. And it's certainly not never. This is very definitely a sometimes question. Right, let's jump into a question. So here we can see we've got a number and we're dividing by 3. My first recommendation for these questions is to give yourself plenty of room. So 9, 9, 3, 6. And notice I've left myself room. If I need to do any numbers left over, any remainders, I absolutely can. And the number I'm dividing by always goes outside. So here's the 3 on the outside. So the way this is going to work is we're going to ask ourselves how many times the number on the outside goes into each digit. And we're going to write the number of times it goes into each digit at the top. And we'll see if there are any left over, we'll see what happens. But we're not going to do that for now. To start with, how many 3s go into 9? Well, if I do my 3 times table, 3, 6, 9, I can see that is 1, 2, 3 times. So it goes in 3 times. I'm now going to repeat that process for each digit. So 3 goes into 9, still 3 times. 3 goes into 3, 1 time. And 3 goes into 6, 2 times. And that is going to be our answer. What I would always recommend though is this is your working out, so I would always write the answer again nice and clearly in the answer line. You're welcome to underline it if you choose. So that, at the most fundamental level, is how the bus stop works. You need to make sure you can put each question in the right place and work out how many times each number goes in. So I do have some questions here for you to try. So please have a go at these 4 questions now. Make sure you get the answer. My recommendation would be to actually write out the question and the answer so you've got a record. Pause the video, give these a go, and when you return, we will go through the answers and make sure you've got them correct. Okay, I'm about to go through the answers, so if you've not done them, pause now. Otherwise, hopefully you're ready. Here they come. So 4866, the answer to that will be 2,433. For 8488 divided by 4, we're going to have 2,122. For 963 divided by 3, we're going to have 321. And for the last one, a bit of a challenge, 39,636 divided by 3, we're going to have 13,212. And those are the answers to those. So please give them a mark for me, and then we'll move on to the harder questions. So, imagine the following question was set up on the board at school in front of you. Saki has been asked to explain why this is true. And she says the 3 divided by 3 is 1. The 6 divided by 3 is 2. And 9 divided by 3 is 3. Therefore, the answer is 1, 2, 3. What has she gotten wrong? What has she gotten wrong with this statement? It's that she's close, but what has she said wrong? Pause the video here, have a go, write it down, or have a talk about it with anyone with you, and then I'll reveal the answer when you click play again. Okay, now this is a really interesting question because actually it's very easy to do this question, and if we're saying it properly, you'll see how it changes. This number here is not a 3. If we think about place value, that is actually in the hundreds column. So what she should say, really, if we're being perfect, is 300 divided by 3 is 100. And that's why we wrote 100 in the hundreds column. That 3 is not dividing a 6. What number is that? It's a 60. So we should be saying 60 divided by 3, in that case, is going to be 20, or 2 tens, which is why we've got 2 in the tens column. And finally, for the last one, we've got 3 divided by 9, and 9 divided by 3, and it really is a 9 this time, so we can say 9 divided by 3, which is 3. And that is where our answer comes from. So it's always worth just bearing in mind that that is not a 1, it's a 100, that is a 2, lots of tens, so that's a 60, that's a 300, and it's important to make sure as much as you can you get those wrong when don't get those wrong, get them right around when you're thinking it through, because it explains why we're putting the answers where we are. Right, now moving on, we're going to look at slightly more complicated ones where it doesn't divide in exactly. So I've got 2 examples at the top. I'm going to do the 2 examples at the top, and perhaps you can have a go at the ones underneath. So 6, 4, 5, 2 divided by 4. In this case, does 4 go into 6? It does indeed. It goes in 1 time. But now it doesn't go in exactly. There is a remainder, and that remainder is 2. Now, because I know that the remainder of 2 is 2 thousands, I can move that over, and 2 thousands is going to be the same as 20 hundreds, which is why I've now got a 24 in my hundreds column. And so when I ask myself how many 4s go into 24 hundreds, I can go through my times table and say it goes in beautifully 6. Therefore, it's going to be 6 hundreds. There's nothing left over, so there's nothing to carry. How many times does 4 go into 5 or 50? Well, 4 goes into 50 1 time. Remainder 1. And again, when I carry one 10 over, you can see here, look, it's now acting as a 10. The 2 plus 10 is where this 12 has appeared from. So now I can say, how many times does 4 go into 12? And of course, the answer is 3. So the answer to this question is 1,613. Let's have another go at one more question just to make sure we've got it stuck. So I'm going to write my answer in 9,935 divided by 5. And let's go through the process. So how many 5s in 9,000? Well, it goes in 1 time, remainder 4. There are 4,000 left over that I carry over to the next column. So I now have 49 hundreds. How many times does 5 goes into 49 hundreds? Well, 5 times 9 is 45, so it goes in 9 times. If I need to, I could just jot it off in the corner, 45, that was what I've said, 5 times 9 is 45. So now I can ask myself, how many times does 45 go into 49? And what's the remainder? Well, the difference between those is 4, so 4 hundreds is the remainder, so I'm going to carry my 4 hundreds over to make 40 tens. So now I've got 43 tens in total. How many times does 5 go into 43? Well, in this case, it goes in 8 times. The remainder is 3 tens. So I carry those 3 tens over to make 3 tens and 5, 35, and that goes in 7 times. So 1, 9, 8, 7 is my final answer. It's always nice to underline them when we're done. So everybody, those are 2 examples of how we deal with numbers when they don't go in exactly and we have these remainders, these leftover numbers, and how we carry them down to the next place value and use them there. Please have a go now for me at questions 1 to 6. Give it a go, pause the video, and come back when you've had a go at the answer, including if you'd like to have a go at this worded question or this reasoning question. Okay, everybody, let's quickly run through the answers. I'm just going to reveal them now. Please utilise them to mark your answers and compare and contrast and see how you've gotten on. Hopefully you agree with these. And what I will say in this case, explain what's gotten wrong. Well, the first obvious clue is the number has gotten larger. And usually when we're dividing by whole numbers, we would expect our answer to get smaller. And then specifically, it should have gone to 1,863. Should have been the answer. So they've gone all sorts wrong. I think what they've done potentially is they've gotten their remainders and their answers the wrong way around. So 5 goes into 9 1 time, and they seem to have written the 1 down here, with 4 left over. So I suspect it should be something like swapping these over. I think that's the kind of mistake that I expect they've done here. So very well done if you spotted that, and well done if you got a corrected answer of 1,863. Okie dokie, everyone. I've got here actually a few more practice questions, so we can give these a go. If you've got the hang of these, if you feel like you don't need the extra practice, welcome to skip ahead in the video, but we will just do these now because I think it's a bit more practice, perhaps some slightly harder questions. Again, as before, I'll quickly whiz through these examples, but again, if you need to pop ahead in the video, that's absolutely fine. Let me just do them now. So 1947 divided by 3, 3's into 1. This time, don't go at all. So we have to say 0 times. And this is the difference between the ones now and before, where the number I'm dividing by is larger than the first digit. Now what's very important to realise is we've not used that 1,000. We can't just ignore it. So that entire 1 becomes a remainder. And so that 1,000 gets carried over into the hundreds column. So now 3's into 19, which are 3 times table. So luckily 3 times 6 is 18, so it goes in 6 times. And there is a remainder between 18 and 19 of 1, so we carry the 1 over. Since it was 100, it gets carried over to become 10 tens. So now we have 14 tens. How many 3's go into 14? Well, 3 times 4 is 12, so it goes in 4 times. The remainder is 2, and luckily 3's into 27 does in fact go 9 times. So we have 6, 4, and 9. So hopefully you can see with potentially the problem, the difference. This time we had to carry the whole of our number over, because if you don't use it, if you can't use it, you just write 0 down and carry on. Please make sure you are adding the 0 in, otherwise your place values can all get messed up. And as we talked about earlier, it's really important to have the thousands and the thousand, hundreds and the hundreds, and so on. Really useful. Okay, next example. So we have 1,208 being divided by 4. Does 4 go into 1? No, it does not. A very common thing to do is have people accidentally go the other way and they say, sort of, right, does 1 go into 4 this way? And that's not right. We're not dividing by 1, we're dividing by the 4. And you cannot fit 4 people into 1 seat, for example, so it doesn't go, it goes 0 times. So now then the answer is, or sorry, the result is we've not used the 1000, so we have to carry it over. Does 4 go into 12? No, it doesn't. We have to write that. Oh, sorry, no, it doesn't. Yes, it does, excuse me. It goes in 3 times, so 4 goes into 12 3 times. It's 100, so it's 300. Does 4 go into 0? This is where no, it does not, so we simply write a 0. And does 4 go into 8? Yes, it does, 2 times. So our answer is 308. And at this point is when I would write 302. But you notice how in both of these, I include the 0 in my working, and then only not in my answer at the end. Right, everybody, again, I've got 7 questions here. Please pause the video and give these questions a go, see how you get on. And again, please feel to give a go or have a try at this problem-solving question. It's slightly more worded with a bit more going on. Okay, ready, pause now. I'm about to reveal the answers. Here they come. So, we've got 93, 871, 926, 1309, 407, 805, and 901. And for the problem question, for the first we had to divide 3,642 by 6, which gave us an answer of 607 packs. And if each pack cost this much money, bit of a challenge question this one was quite hard, we had to multiply them together and got £1,110 and 81 pence. Again, if you need a bit more support with the multiplication, please feel free to have a look on the portal for our multiplication video. Right, now guys, on to the last one. Well, the last of the set practice areas. Again, much the same way as before, I'm going to run through. These are a bit more challenging because they are decimals. But hopefully, as you'll see, although they look a bit scarier, they're actually much the same as all the others. Let me show you. So here we're going to put our 6.28 inside the bus stop. We're dividing by 4, so that goes outside. The one thing I'm going to do is when I have a decimal here, I'm going to make sure I jot the decimal down in the equivalent position above, because that's going to help keep my place values all nicely lined up. And then you'll see it works much the same as before. So how many 4s into 6? Well, it goes in 1 time, and the remainder is 2. How many times does 4 go into 22? Well, in this case, 4 times 5 is 20, so it goes in 5 times, and the remainder is 2. And if 4 times 5 is 20, 4 times 6 is 24, so 4 times 7 is 28. So my answer is 1.57. So other than writing the decimals down, it works exactly the same way as if the decimals weren't there. So I think that's a really useful thing to know, not to be able to get put off, just cool, calm and collected and treat it exactly the same way as before. So here we've got a 3 being divided into 18.09. Does 3 go into 1? No, it does not, so we carry the 1 over. Does 3 go into 18? Yes, it does. We have to work out how many times. So 3 times 5 is 15, so 3 times 6 is 18. We make sure to put the decimal in the equivalent position. 3 does not go into 0 times, there's 0 left over. 3 into 9 does go 3 times, so there's my 3. So my answer is 6.03. So hopefully that's taken something that looks a bit scary and shown you that actually quite manageable, it works much the same way. Right, you know the pattern by now. I'm going to ask, please, everyone, if you wouldn't mind having a go at the following questions, pause the video, and then come back when you'd like to see the answers here. And again, do please feel free to have a go at the problem-solving question, although again, it's a bit more challenging. It does involve tying and perhaps a few other skills from other areas. Okay, everyone, here the answers come. Get ready. So we have got the answers coming up now. Let me just reveal them. You can have a little look and mark your answers, please. Again, if you need to pause the video so you can get all the answers marked and compare them, I think it's a really good idea. And for the problem-solving question, we had to do 111.15 divided by 9. This is important. It tests a good understanding of what happens if you get an amount left over. Well, if they could buy 12 and a bit CDs, well, a bit of a CD doesn't really do much good. So the actual final answer, I think, should be 12. They could buy 12 with some money left over, which is not enough to buy a whole CD. And then finally, how much extra does she need to spend all the money on CDs? Well, for this, I needed to work out what 13 CDs would be worth, which is £117. and then the difference between 117 and the amount of money she had will give us what Caitlin needs to get to her answer. So that was my working out. 117 came from me saying, well, okay, to the nearest whole number, what would she need for 13 CDs? Right, everybody. To finish on a very similar style of question, I've got a few practice questions that are equally worded in case anyone wanted some more longer form practice questions. These might involve a bit of division and multiplication. Normally the first part is division, the second part is multiplication, but they all apply the same skills. So if you'd like to have a quick go now at the following questions, please do. Pause the video. There's 4 questions here, some of them with 2 parts and some of them with just 1 part. Pause the video and then we'll quickly whiz through the answers and that will be the end. Okay, everybody, here come the answers. So if you've not quite finished, pause the video, because here they come. So, Gemma needs to have 307 biscuits. And if 1 pack of biscuits is 97p, then we need to do a small packet holds 7 biscuits. She needs to buy 307 lots of 97p, which is, oh my goodness, 290 pennies. Now, actually, what I think probably I should do, if that's the answer in pennies, I might want to convert that answer to pounds. So actually, I don't know if you did that already, and since it didn't ask, both answers will be correct. That means she's going to need to have £297 and 79p. So either of those answers would be appropriate. It's worth making clear. The 9 workers from a chocolate factory go on an outing. The owner gives them 9,621 chocolate bars to hand out to the public. How much do they hand out each? Well, there's 9 workers, so we have to divide our answer by 9, which means they will have each had to hand out 1,069 chocolate bars. That sounds like a really cool job. Unfortunately, it's a very bumpy journey and everyone is sick. Oh no! The coach driver charges them £88.20 to clean up the mess. How much do they have to pay each? Well, in this case, they're going to split £88.20 between them. So the answer should be, oh, that's gone the wrong way. Let's fix that now. It's £88.20 divided by the 9 workers, so you should have had an answer of £9.80p. I can tell what the person has done anything else. They've times it. Let's fix that right now. So £9.80p each. Number 3, a giant tube of Smarties has 1,806 sweets in it. Juan wants to share them equally between himself and his 6 classmates. Well, here, alarm goes off. This is a bit of a trick question. So I'm going to give you guys a chance, if you did fall for this trick, to fix it before I reveal the answer. If he's sharing them between himself and 6 classmates, how many people is that? If you accidentally divided by 6, I'm going to give you a chance to change it now, because there are in fact 7 people, him and his 6 friends. So you should have divided by 7. And 1806 divided by 7 should give an answer of 258. So if you didn't get the answer there, please fix that for me now. Nasty trick question, a good one to see here, so you know to watch out for it. We're talking about himself and a few more people. Number 4, the roadside florist only sells roses. At the end of the day, he's selling them for 5 pence each. A man asks for £28 worth. How many roses will he get? The reason this is a bit of a sneaky question is you've got pennies combined with pounds. So if before I started, the first thing I would have done is realise that that is the same as spending 2,800 pennies. So you need to do 2,800 divided by 5, which I think is going to be quite a big number, 560 roses. And finally, how much would 2 dozen roses cost? Of course, the challenge here is, do you know what dozen means? And if not, I'm going to tell you now, it's 12. So 2 dozen is 2 lots of 12. So this is really just asking you, how much would 24 roses cost? And again, quite interesting terminology, nice to be aware of. So we need to do 24 times 5p, which I think gives us an answer of £1.20, which sounds very reasonable to me. Right, everyone, I hope that was useful. Bit of revision, bit of practice. Of course, any questions, don't hesitate to come back to your tutor at the centres or watch some of our other hopefully helpful videos that are also on the portal. But everybody, thanks so much for your time. See you again soon. Bye-bye.